Now, let's go back to the simulation, the inspector. Uh, yeah, so we ran the simulation several times already. One time we used manual, but another time we used automatic PID. When I compare my baseline using this compare tab, uh, my baseline as the run 1, and I'm going to compare it with the run 5 that I have done. So as you can see in the figures, the difference between these two signals are completely defined and you can easily compare them. So I guess for this example, we expected the results to change. Obviously we are going to be out of tolerance, but I think one of the reasons why people use this comparison tool is, let's say you have a model, you want to, look at changing some parameters to maybe optimize the performance, but you don't want the actual results to change. And you just want to make sure that the changes that you make don't significantly change the desired response. So I just changed the tolerance to 1 to show you how the figures change. So that's what it is. Sometimes you just want the output to be same, and in that cases you could set a tolerance and check for the results. Okay, so you can imagine your model, and this is only 2 signals. Most likely you're going to be interested in more than 2 signals in your own models, and it will track all of those comparisons here. In addition, you can also send these results to MATLAB figures, and I can try doing that, and that would be a MATLAB figure here, and you can basically add additional information like titles and so on. I don't know, I mean, you can do additional data manipulations right here. It's nice being able to go from this tool to MATLAB figure because a lot of people are used to working with MATLAB. And instead of pulling the simulation data and then plotting it by yourself, writing code and doing that, you can automatically create figures from here. So what if you want to store all this data? It's pretty easy to do that. You can save this data right from the menu here, and I can create a comparison data MLDATX file. It stores as a MLDATX file, which is being represented within Simulation Data Inspector. So when I close the MATLAB and come back tomorrow and want to continue with my analysis, I can simply load the MLDATX file using the Simulation Data Inspector. And then I will be able to compare those signals. So that's the benefits of Simulation Data Inspector. It goes one step beyond visualizing. It helps you compare and do additional analysis right from the UI itself.